This problem, number 1, is a combustion problem. And the goal of this problem is we want to calculate the grams of carbon dioxide that's going to be produced. The first very important step is to write the balanced chemical equation. And the balanced chemical equation is you have octane reacting with oxygen Don't forget that oxygen is diatomic to produce carbon dioxide and vapor water. And we can go ahead and balance this with the following coefficients. In this problem, we're given the moles of oxygen, which is 35 moles, and we need to find the grams of carbon dioxide produced. So let's go ahead and solve for problem A. We start off with our 35 moles of oxygen, and we're going to use our mole to mole ratio from our balanced chemical reaction. If you look at our balanced chemical reaction, there's a mole to mole ratio of 25 moles of oxygen to produce 16 moles of carbon dioxide. So let's go ahead and write that conversion factor down. 25 moles of oxygen will go to produce 16 moles of carbon dioxide. And since the problem asks for your grams of carbon dioxide produced, we're going to use the molar mass of carbon dioxide to get to the grams of carbon dioxide. Your moles of carbon dioxide cancels out, moles of oxygen cancels out, and we're left with 986 grams of carbon dioxide. In the second part of this problem, we're given 54 grams of octane, and we want to calculate the grams of water. So we're going to start off with what's given in the problem. We have 54 grams of octane, and we want to convert this to moles by dividing by the molar mass of octane. And if we look at the mole to mole ratio, there's 2 moles of octane for every 18 moles of water. And after we have the moles of water, we know that for 1 mole of water, we have 18.02 grams of water. So moles of water cancels out, moles of octane cancels out, grams of octane cancels out, and we're left with 76.7 grams of water as our answer. In the next problem, we want to find the molecules of oxygen gas needed to produce 17 moles of ozone. The first step in this problem is to write down the balanced chemical equation, which is O2 going to ozone. And we can balance this by putting a 3 in front of the oxygen and a 2 in front of the ozone. We have 17 moles of ozone. We can go ahead and start with what's given, with our 17 moles of ozone. And according to our balanced chemical reaction, there's a mole to mole ratio of 2 moles of ozone for every 3 moles of oxygen. And for every 1 mole of oxygen, we have Avogadro's number of oxygen molecules. So moles of O2 cancels out, moles of ozone cancels out, and we're left with 1.54 times 10 to the 25th O2 molecules. In problem 3, we want to determine the grams of oxygen gas given a combustion reaction with methane. So always the first step, we want to write down the balanced chemical reaction. And so we have methane gas reacting with O2 gas to produce carbon dioxide and vapor water. And we're going to put a 2 in front of the oxygen to balance this. Well, we always start off with what's given in the problem, which is 694 grams of methane. And we're going to divide by the molar mass of 16 to convert to moles of methane. And according to a balanced chemical reaction, there's 1 mole of methane for every 2 moles of oxygen. And for every 1 mole of oxygen, we have 32 grams of O2. So moles of O2 cancels out, moles of methane cancels out, grams of methane cancels out, and our final answer is 2.78 times 10 to the third grams of oxygen.